Hello viewers, Wagadaruna taking you through the story for A-level pure mathematics. And this video we are going to go through the marking guide for Senior 5 Math Paper 1 end of term 1 for the year 2024. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So these are the papers we hope to upload, and in this video we are going to go through the paper for Naalya Senior Secondary School. There are some books which you will need in this A-level. So for principal mathematics, there are 4 books: Math Paper 1, Math Paper 2, Topical Question Bank, and Termly Papers with marking guides. For subsidiary math, it is only 1 book with all notes, Termly Papers with marking guides, and also UNEB Papers with marking guides. For physics, there is Physics Part 1, Physics Part 2, Topical Question Bank, and its solutions. So if you need the copies, contact the author on this contact. So now let's start with question 1. Question 1 says, solve the simultaneous equations. So in your O-level, simultaneous equations had 2 unknowns and they were linear. But now they can make simultaneous equations with 3 unknowns or 2 unknowns, but when there is a power somewhere. So these are 3 unknowns and they are all linear. Linear means there is no power on either x, y, or z. So first is to label the equations. Remember, your solution must be self-explanatory. In other words, what you write must be well explained. So we are going to first write the equations, equation 1, equation 2, and equation 3. Then we can start. So you choose what to eliminate. Here I've chosen to eliminate z. So when I eliminate z, it means equation 1 plus equation 2, I'll come and add them. When I add this, gives you 3, this gives you -2, and this cancels, this gives you +2. That is equation 4. So I used this and this to get equation 4. Next I'll use another pair. So here I've chosen to use 1 and 3. So if I want to eliminate z, you will realize that here there is 3, here there is no. That is why I have to multiply by 3. So when I do that, I'll come up with this. So this with this gives 6, this gives 5, this cancels, this gives 11. So those are now 2 equations and 2 unknowns. So I can solve them now. So here I've chosen to eliminate x. So when I subtract, it gives 0, this gives that, this gives this. Meaning I can now get the value of y. So before we go to the next slide, let's see marks for the slide. So far I've got 2 marks. Let's see the third mark. When I make y the subject, I'll come up with y as that. Then from equation 4, substitute for y and get the value of x. Then from equation 1, substitute for x and y to get the value of z. And that's what they wanted. Then question 2, express this into partial fractions. Now the coverage, different schools approach the syllabus of A-level differently. So in case you find a topic you have not yet covered, there's no need to worry. So don't say that you are very behind. It is because different schools approach the syllabus in a different way. Some schools have 3 teachers teaching 1 paper, others have 2 teachers teaching 1 paper, others have 1 teacher teaching 1 paper. So the coverage will be a little different from school to school. So some have not yet covered partial fractions, but this particular school covered it. So you're not yet covered, you can either choose to skip the question, or you first pause and go in the playlist and watch that topic of partial fractions. Then you can easily follow. So first is to decompose this fraction into corresponding partial fractions. And you should remember that there is an equivalent sign at this point. So this is this, this is this. These are called constants. So next is to compare the numerators. What you do, if you put this under one LCM, what will you get? You realize that this here will get this times this to give you this, and this times this to give you this. Next is to put different values to get the value of the constant a and b. So the preferred one is that if I make one term 0, what will can't I get the other? So when I choose to make this term 0, it means x minus 3 is equal to 0. That's why you got x equal to 3. Substitute here, get this 5, here get that, this is 0. That means I can get the value of a. Then also, when I make this equal to 0, x will be negative a half. So putting negative a half here, I'll get this. This remains. The whole of this is 0. Then put it here, you get that. Simplify and get the value of b. Then you can substitute for a and b here. And that's what they wanted. Then question 3, solve the equation this for values of theta from 0 to 360 degrees. So first we shall write that, then we divide throughout by cos squared theta. When you do that, this divide by cos squared theta, you get tan squared theta. This one divide, this cancels and remain with tan theta here. The whole of this cancels, that's why there's just 6 here. Now that is a quadratic equation in tan x, meaning I can solve it using the quadratic formula to get two values of tan x. But remember, they want you to solve for x. So, well, for tan x equal to 3, these are the two values. How are they got? You come and draw your SOHCAHTOA because tan is positive in the first and third quadrant. So the first angle here is this. The second angle is from here up to here, which is 180 plus 71.57 to give you this. Same applies to this. Draw your quadrant. So arctan 2 gives you 63.43. The first angle is from here to here, which is this. The second angle is from here up to here, which is this 180 plus 63.43. And that's what they wanted. Then question 3 says the second term of an AP is 5 and the sixth term is 14. Find the sum of the first 10 terms. So the second term is a plus d, which is 5. Then the sixth term is a plus 5d, which is 14. Then you solve those two equations. If I choose to eliminate a first, I'll come up with d as 9 over 4. Then when I substitute d in equation 1, I'll come up with the value of a as 11 over 4. After getting the values of a and d, I can now get the sum of the first 10 terms. Quote the formula, substitute for n, for a, n, and d. Then use a calculator to get the required sum. And that's what they wanted. Question 5. Solve for x in this. So it's under logarithms. So first you realize that the bases are different. So you have to convert into the same base. Getting the reciprocal of this, the base changes to 5. Then let y be equal to log base 5 of x. Substitute for y. Multiply throughout by y. to get a quadratic, which can be solved using a quadratic formula to give you two values of y equal to 2 and y equal to -1. But remember, y is equal to log base 5 of x. So I'll come and substitute, replace this with this and that. Then here to eliminate logarithm, you say 5 to the power 2 is equal to x, and here 5 to the power -1 is equal to x. Therefore 5 to the power 2 is 25, 5 to the power -1 is 1 over 5. And those are the values they wanted. Question 6. Find the equation of the line that passes through a point this and perpendicular to this. So first of all, for this given equation, for this given line, the gradient is 2. But they said the equation of the line they want is perpendicular to this. So that means that when I multiply two gradients, I should get -1, provided those two lines are perpendicular. So with that, I can get the gradient of the second equation. Okay, so now I have the gradient here, and I also have a point here, which is 3, 2. So now that I know the gradient and a point on that line, I can easily get the equation of the required line. And that will be the required equation. So that's what they wanted. Question 7. Eliminate theta from the following pair of equations. Riemann 1 we have that, Riemann 2 we have that. So first of all is to make these trig ratios constant, the subject. So here from this, cos theta is equal to x over a. From this, sin theta is equal to y over b. Then I remember the trig identity that cos squared theta plus sin squared theta is equal to 1. Then I'll substitute and multiply by the LCM. And that's what they wanted. Riemann 2 still cot, here make it the subject, become x over a. Sec, make it the subject, become y over b. Then I remember the identity that sec squared theta is equal to 1 plus tan squared theta. Then I'll substitute for sec and for tan. Tan is the reciprocal of cot. So that's why I get here that. Multiply throughout by the LCM to get that, and we have eliminated. And basically that's what they wanted. Question 8. Solve the equation this. So first is to square both sides. Then I expand this squared, then twice the product of this is here. This squared gives that. Then collect like terms here. I'm going to collect like terms. When I take this 4 this side, it becomes 3x. Then I am going to again square both sides to come up with that. Expanding this gives this, and expanding this gives that. So before I go to the next slide, let's see marks for this slide. So now I've managed to remove all the square roots. Next is to rearrange to get a quadratic equation, which can be solved using the quadratic formula to get the two values of x. So that's what they wanted, but you need to verify. So questions involving square roots, you need to verify. So let's see when x is equal to 5. Substitute 5 here, here, here. And simplify to see if the left hand side is equal to right hand side, which is true. Then when x is equal to -3, -1/3, substitute, simplify. So here it is true that this is equal to this, but you know what is funny? Negative square root is undefined. Therefore, x cannot be equal to -1/3. So we shall conclude and say x can be equal to -1/3, implying that x is equal to 5. That's what they wanted. That was section A. Now we shall go to section B, which contains each question has 12 marks and a total of 60 marks. Part A says if A is that, cos sin A is that, and cos B is that, where A is obtuse. Note this word, A is obtuse, and B is acute. Find the values of sin A plus B and tan A minus B. So let's start with part A first. So first, remember that obtuse angles lie in the second quadrant, while acute angles lie in the first quadrant. So I'm going to first draw for both angles. So that is for A, which is obtuse. This right angle triangle, meaning that this one can be got from Pythagoras theory. AB is acute, so it is in this first quadrant. Still by Pythagoras theory, you can get that remaining side. Then you remember that cos is adjacent over hypotenuse, but because A is in the second quadrant, it implies that in the second quadrant cos is negative and sin is also negative. So it becomes negative adjacent over hypotenuse. Tan becomes negative opposite. Sorry, tan A here is negative opposite over adjacent. What about for angles B? B, they are all positive, so sin is positive opposite over hypotenuse, and tan is positive opposite over adjacent. That means that now we can now use the compound angle identity and then substitute sin A is that, cos B, sin cos A, sin A cos B, then cos A sin B, which is this. Use a calculator, you'll come up with this as the answer they wanted. That was Roman 1. Roman 2, they want tan A minus B. Still you have to expand and then substitute. For the numerator, we have tan A minus tan B. Denominator, we have 1 plus tan A times tan B. So when I simplify, numerator will become this, denominator will become this, which gives the total of this. That was part A. What about part B? So for part B, solve the inequality this. Here, the first thing to do is to take all the terms on one side. If you cross multiply this step, it is not okay. Then get LCM, in other words, combine the two into one quotient. Correct like terms, then you can get the critical values. When I equate this to 0, I get this. Equate this to 0, I get this. Then you can now tabulate. So for values less than this, what happens? So I can choose -6. -6 here, you get a negative. -6 here, you get a negative. So that when you divide, you get a positive. Then values between -5 and +3. I can choose 0. 0 here, you get a positive. 0 here, you get a negative. So division gives a negative. Values beyond 3, I can choose 4. 4 here, you get a positive. 4 here, you get a positive. So division gives the positive. Then you'll go back here. Greater than or equal to 0 means we need positive values. So the solution set will be that. Now here, this positive was corresponding to x less than negative 5. But in my solution set, I'm having x less than or equal to negative 5. Why is it so? It is because the given inequality had or equal to. So if it has or equal to, you also put or equal to on your final solution set. Not here. Here you don't put. But at the conclusion, you must put it there. So basically, that's what they wanted. Then question 10, part A, express this into partial fractions. Here the trick was on this. A student was supposed to realize that this is a difference of 2 squares. So first come and deal with that difference of 2 squares. So this will become this. Then I can now decompose my fraction into different partial fractions. Then I can now compare the numerators. So this A will have a product of this and this, which is here. B will have a product of this and this, which is here. And C will have a product of this and this, which is here. Next is to put different values. So if I, for example, if I want the whole of this to be 0, it means y is equal to negative 3. So I'll come here and put y equal to, actually they are different. There is that, then there are different values of y raised to them, all of them. Here, it means y is equal to negative a half. Here, it means y is equal to positive a half. And here it means y is equal to 3. So we shall use those 3 values. So using y is equal to a positive a half, I'll come up with that. Simplify and get the value of a. Then put y is equal to negative a half, substitute, simplify, get the value of b. Then put y is equal to negative 3, substitute, simplify, and get the value of c. Then from there you can quote our partial fractions they wanted. So that was part A. Now we shall go to part B. Part B says solve the equations this and this. So in other words, we want you to solve them simultaneously. So given this, you have to change the smallest base, which is 2 to the power 3, 2 to the power 2. Same base, you cancel them, you remain with this. Here, you remain with the powers alone. Then you collect like terms. This goes this side to become 1. This comes this side to become 5y. That is equation 1. Then the second equation which was given was that. So this one, in indices, it is 5 to the power 6. Same base, you cancel them and remain with the powers alone. Those are 2 equations, 2 unknowns. So I can use the method of substitution by substituting equation 1 into equation 2. Collect like terms and then divide through by 24 to get y squared. Put square root on both sides to get the values of y. Plus or minus should be same. Then from equation 1, I can get the value of x, which is plus minus 5 over 2. and that's what they wanted. That was question 10. Now question 11, part A says, if this is that, prove that this is equal to this. So that's what we are given. First is to express in terms of sum and product. Sum product. Then take this side to get this. That you put log on both sides. Then you expand this to give you this. But also you need to expand this to give you this. Then divide throughout by 2, and that's what they wanted. That was part A. Part B says solve for x in this. That's what is given. This becomes 2 to power x, 2 to power 2. Then substitute, change variable, let y be equal to 2 to power x. So this becomes y squared minus 6y plus 8, which is a quadratic. So I'll solve it using quadratic formula to get two values of y. Then I'll remember that y is equal to 2 to power x. So good thing is same base, so x will be 2, same base, x will be 1. And that's what they wanted. Then question 12 says solve the following equations. Part A this, part B that. So let's start with part A. Part A, you realize that this and this are the same. So you first let, then you substitute for y, then multiply throughout by y to get a quadratic equation, which can be solved using quadratic formula to get two values of y. So for each value of y, we shall remember this. So we shall come here and say, for y equal to 4, that is equal to 4, which gives a quadratic, and you solve it using quadratic formula to get two values of x. For y equal to 3, still you get a quadratic, which can be solved to get the two values of x. And that's what they wanted. So part B, I want you to realize something. This and this are the same. This and this are the same. So that means it is a symmetrical equation. So symmetrical equations have a particular procedure to solve them. And the first thing is to let y be equal to x plus 1 over x. When I square it, you'll come up with this. Simplify with that, but I want to make this the subject, so I'll come up with this 2 has to go this side to give you this equal to y squared minus 2. So for symmetrical equations, this is the first thing to do. Then after that, you can now go to your given equation and start solving it. So let's see how the equation is solved. This is what we are given. The first thing to do is to divide. Okay, you are going to collect like terms. The terms I mean are the putting coefficients, similar coefficients next to each other. So this with this will be put next to each other. This with this will be put next to each other. Then from there we divide throughout by x squared. This gives this, this gives this, this gives this, this gives this, this gives that. Then from there you factorize by grouping. So we're going to group this, factorize, group this, factorize. Okay, now you can substitute because you already know that this is equal to this and this and this is equal to this. So I can come and substitute to change variable. I think now it has become a little simpler. So I can expand to get a quadratic equation which can easily be solved. So on solving, I'll get two values of y, but I'll remember that y is equal to 1x plus 1 over x, which gives a quadratic which can be solved to get the two values of x. What about for y equal to 5 over 2? Substitute, multiply by the LCM to get a quadratic equation which can be solved to get the two values of x. And that's what they wanted. Question 13, part A says, if the roots of the equation this differ by 4, show that this is equal to that. So let one of the roots be beta, meaning the other root will be beta minus 4. So that's a given equation. Sum of roots will be equal to negative b over a. Simplify and make beta the subject to give you that equation. What about product of roots? Will be that. Then you substitute for beta. The whole of this is beta and beta. So this and this gives you negative 2, which is there. Then you realize that it is difference of two squares. Here, do you see something? Difference sum. So it is difference of two squares. You use that method, this squared, this squared. Then open brackets and multiply throughout by a. So I have chosen to multiply a throughout. Then rearrange, make this a subject, you come up with what they wanted. So that was part A. What about part B? Part B says, when the polynomial px is divided by x minus 1, the remainder is 5. And when px is divided by x minus 2, the remainder is 7. Find the remainder when the same expression is divided by x minus 1 times x minus 2. So let the remainder be in the form rx equal to mx plus n. So when this is the divisor, x is equal to 1, meaning that r1 will be equal to where there is x, you put 1. You come up with equation 1. Then for this divisor, x is equal to 2, so r2 will be given by this, giving you equation 2. Then I have to solve them simultaneously to get the values of m and n. So let me first begin by eliminating n by subtracting. This cancels, this gives you m, and this gives you 2. So now that I have the value of m, I'll come to equation 1 and substitute for m to get the value of n. Then I'll remember that my remainder was in the form mx plus n. So I'll come and substitute for m here and n here. And that's what they wanted. So this was not supposed to be there. Then question 14, part A says, find the coefficient of the term with x squared in this. So first we shall quote the general term. Then we try to expand so that we make x alone. So let a be the coefficient of x squared. It means that ax squared will be equal to this general term. By comparing, it means that a is this and the whole of this is this. So the powers should be the same. Now we shall come and equate the powers. Expand and simplify to make r the subject. That means that the quotient of x squared will be a, which is this. So substitute for r, and also here substitute for r to get the output. And that's what they wanted in part A. Then for part B, expand this as far as the term including x cubed. Taking the first three terms, evaluate these to three significant figures. So that's under binomial expansion. So shall come and remember that given this form, in indices we can write it as that. So shall expand each of these. For this one, expand up to the third term. The formula for expanding is there in your logbooks. So we begin with this 1, then plus this power times this to power 1. Okay, then plus this power times power minus 1. So a half minus 1 is negative a half. Okay, then times this here, but this time it is squared over 2 factorial. Then next, still write this here, and then add on, multiply by this value minus 1 to give you this. Then from there we say multiply by this cubed over 3. So those are the terms they wanted: first term, second term, third term, fourth term. So simplify, you come up with that. Do the same for this one and simplify. So now that you have got the expansion for this and for this, we are going to multiply the two to get what they want. So here I have to open brackets. So 1 times the whole of this gives you this. Then 5 over 2x times the whole of this gives this. Negative, okay, this negative is here minus. So you shall say 125 over 8x squared times the whole of this gives you this. Then this times the whole of this gives you this. Now why are we putting these dots? It is because they want us to stop at x cubed. For example, this times the whole of this times this is here. But if you say this times this, you get power 4, which you don't want. That's why you're putting the dots. So I simplify to come up with that. Then you can go to the hence part. Hence part, they wanted the square root of 14. So I have to equate this one to 14 and see the value of x to use. So when I cross multiply, I'll come up with the value of x as that. Meaning that from this I substitute for x root 14 will be equal to 1 plus 5 times 1, 13 over 75. 25 over 2 times 13 over 75 squared to give you this, but they wanted the answer to 3 significant figures. And that's what they wanted. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on Math Part 2. It's nearby the end of Term 1. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Also, if you know of any student who is not yet on this platform, please share the link of this video with them via social